It's Wednesday night. Welcome to the LAN Tamer stream. We're going to do some not so private VLANs because I'm going to show it to the world here. But we're going to do some, I'm going to redo basically the private VLAN lab tonight. And let me pull up the agenda. So we got private VLANs. I've got an NSX presentation tomorrow at work. So I may, just a real high level review. I may regurgitate some of that for the stream. I've been saying I'm going to do that, but tomorrow will be a practice run. We'll practice at work, and then we'll do the good run here on the stream at some point, I think. And then SharkFest, I've been reading that that's going on right now. It seems like an interesting event. Looks like a number of people, I've been seeing on Twitter, a number of people going to that. In fact, that leads into the first meat chunk for tonight to feed the lions here. This is packettrain.net. A lot of stuff on Wireshark there, I'm noticing. First time I've gone to that. But good tip there about combining columns in Wireshark and a good use case. And then I missed it today. There was another VIRL live session that I missed, developing your programmability skills with VIRL, created by CiscoVIP Mark Holm. I missed it. I had work going on. I had outage call, and I just couldn't get away, even during my lunchtime. So, good thing though is if you watch this page, at some point the recording is going to be made available, and I'm definitely going to go back and watch it. And then we're going to get into whip cracking private VLANs. I didn't feel good about how things went down yesterday. I had issues with the lab, so I couldn't even really redo it. But I plan, I'm not going to be able to do a whole lot tonight, but I just was left feeling, just had a bad feeling. Like I even woke up at 1 a.m. this morning, and I was thinking about technical stuff. And it was hard for me to get back to sleep. I was thinking about my NSX presentation. I was thinking about how I failed in the private VLAN lab. It was bothering me. So initially I came here, let's do some IP routing. Like, nope, we're going to go back and do private VLAN. So let's go back and do that. And I've loaded up the topology. We've got running the basic layer 2 switching topology. And let's get our stuff going here. Let's get the chat window. By the way, covering up the Vanity Fair Star Wars edition from, I think it's a month or two back. They came out with these photos. Awesome photos. So excited. What is it down to, like 5 weeks now? I think it's December 19th. Anyway, let's get a config file out, get the chat window up in case anybody just wants to say anything or wants to say hello, or hey, if you just want to lurk, listen in and watch the struggle, that's fine too. So configs, requirements, the requirements, private VLANs. All right, so configure private VLAN as follows. VLAN 100 is primary. VLAN 1000 is community. VLAN 2000 is isolated. Excuse me. I'm going to try to recall this from memory. Now, it's going to be sloppy. It's going to look sloppy. It's going to look bad. But, I just did this yesterday. So even though I won't be able to recall the commands by memory, I should be able to use the space question mark, space tab, and get through this. That's what I'm going to attempt right now. IP addressing is as follows. 169.254.100.1, switch 1 SVI, VLAN 100. Switch 2 FA024, which is, let's move this guy over here. Come over here. Come here, topology. Get down here. All right. FA024, which would be GI12. 169.254.100.3, switch 3, GI. I believe this is 01. FA020, yeah, GI01 on the updated topology. 169.254.100.4, switch 4 is FA022, which is GI03. Okay, so yeah, basically we've got 2 is going to be host, 3 is going to be host, 4 is going to be host, 4 is going to be isolated, 2 is going to be community, 3 is going to be community. Okay. So yeah, we want .1, .2, .3 can communicate. .4 and .1 and .4. These are the only requirements put in the lab description, but we know basically what that means, right? Which I just described. So I'm going to go flat CLI here. 20, 22, 24, 26. All right. Switch 1, 2, 3, 4. Tell them that the VIRL was 022. I don't know if you saw Twitter today. I posted a view of a data center where I've worked in the past. Such a long hallway. I mean, this is it's not the largest data center I've worked in, but it is the longest hallway I've seen in a data center. Pretty amazing. So I posted a picture. It's an old picture. Let's see if I can pull it up here. Instagram. Let's pull up the grams. This is, yeah, this is my, so I think I've got some likes here. Yeah, this is it. So picture doesn't do it justice, but sure enough, as I describe here, I was working really late. And I got there really late, and then I walked all the way down to where our cage was, and I went through, I don't know, we had, it had retinal scanners, it has fingerprint scanners, there's guards. I don't know, maybe, I think I counted 14 different security checkpoints to finally get into the cage. I forgot my console cable. I believe it's console cable. Might have been power cable or something. I had to go all the way back. Have you ever had that experience? No fun. But I thought that was fun. I thought I'd share that. If you're not following me on Twitter, guys, I'm on Twitter, Instagram at the LAN Tamer, and a Facebook page at /LAN Tamer. Get all the good posts. So here we go. We've got our switches up. And we're going to go do VLAN 1 first. Now, this is what I forgot yesterday, and I hit myself for it. We have to do BTP mode transparent. Can't forget to do that. And then we're going to set up, we have to configure the VLANs, VLAN 100. And I think it's private VLAN primary, yes. Then I have to do private VLAN association, add, and it's 1000, 2000. And then we have to do VLAN 1000, private VLAN. This is the part I missed yesterday, too. Totally blew this. Totally blew it. VLAN 2000, private VLAN isolated. There we go. Anything else we have to configure? Two-way community private VLAN. I don't know what that is. Okay, I don't know if I have to put association here. I don't think so. I think it just has to be on the primary. Okay, so we've installed our VLANs. Now we have to say interface VLAN, what is it, 100? Yep. Interface VLAN 100, IP address 169.254.100.1, 2525250. Private VLAN mapping, add 1000 and 2000. Should run interface VLAN 100. Shut down. Okay. So that must not be right. No shut. Private VLAN mapping. Add 1000. Add 2000. Huh. So I'm trying to add private VLAN mapping. Set the private VLAN SVI. Secondary VLAN IDs. $1,000. I'm missing something here. Let's try to go to the config guide. Come on, config guide. Help us out. I think, was it configuration guide? I don't think it had one. I'm in the wrong place. I'm in NX. Okay, this is just by habit. Product support. Switches. Campus LAN access. 3750X. Command references. And we'll go with 15. I wonder if I'm going to have better success going with this one. Index. Private VLAN mapping command. Wait for it. Wait for it. Wait for it. Wait for it. And then you got to scroll up. All right. On a SVI. Oh, what happened? I scrolled up and it scrolled back down. I swear, Cisco documentation. Ugh. And we got a circle, a bouncing beach ball there again. Use a private VLAN mapping interface command on a SVI. Create a mapping between a private VLAN primary and secondary VLANs. So both VLANs share the primary VLAN SVI. That's what I'm trying to do. Ah, okay. So do I do commas? Let's try it. Private VLAN mapping 1000, 2000. Aha. Okay, I need a little help there, but that's okay. Show run VLAN. See, same thing happened here. So I think what I need to do, VLAN 100 private VLAN association is 1000, 2000. Boom. Nice. Okay. I think our VLANs are now set up. We created the SVI. So now let's configure these ports. Interface range, GI1, 2. What else? GI03, 03, and GI01. And we're going to, actually, we need to default those. Default interface range, GI1, 2, GI03, GI01. Then interface range, no shut, switch port mode access, switch port access, VLAN 100. Aha. Now let's configure our, VLAN mismatch, interface GI12, no switch port. IP address 169.254.100.2. No shut. Yeah, we know switch 3. Stop complaining. 169.254.100.3. And switch 4 is about this time where we hosed VIRL. So fingers crossed. No switch port. IP address 169.254.100.4. No shut. All right. So now ping 169.254. Well, there's something I got to do here still. VLAN mismatch 003. Why is that? Show run interface GI03. VLAN mismatch discovered on GI03 with switch 4 GI03. Why is that? All right, that should go away. So actually, we need to do something else here, don't we? Interface GI12, switch port access, VLAN, private. This has got to be 6 port access VLAN 1. Hold on a second here. Interface GI0, GI12. This is going towards switch 2. Access VLAN is 1000. Yeah. And interface GI01 going towards switch 3. 1000. Then interface GI, what is this? 03. And 2000. All right, show IP interface brief. It is down. Let's bring it up. Show run interface VLAN 100. Private VLAN mapping. That's not right. Private VLAN mapping. Okay, created a private VLAN mapping, primary 100, secondary 1000. What about 2000? Okay, good. Show IP interface brief. Still down. Do we have any ports in VLAN 100? Show VLAN brief. Okay, 2000 active, 1000 is active, 100 says active. What am I missing here? Let's do a shut and a no shut. Still down. All right, let me look at the key. Oh, did I not do primary? Show run interface VLAN 100. Ah, that's what I'm missing, guys. Interface VLAN 100. Yeah, I didn't see an option for that. And it says it's set at 100 as primary. Yeah. Create a private VLAN mapping primary 100. Yeah, but oh, that's VLAN 100. Yeah. Okay, interface VLAN 100 looks correct. Okay, so it looks like I don't have any ports really active, and that's because the ports are not configured correctly. Okay, everything looks good so far except the ports. I'll show you what I mean. So that looks good. This looks good. This looks good. We're in BTP transparent. Our interface VLAN 100 looks good. I got that right this time. What I got wrong is show run interface jazz 03. Okay, this is what I'm missing. Switchport private VLAN. Host association. And this should be 100 is the primary. It has to be primary first. Whether it's normal or extended range, the first one is a primary. Then the second one is, these are going to be, this one's going to be isolated, which is 2000. Boom. So now interface range, GI12 and GI01. Private VLAN host association 100, 1000. Boom. Okay. Oh, and then, well, let's see, show VLAN brief. Show IP interface brief. Still down. Interface GI03. Switchport mode, private VLAN host. GI12 and GI01. Still down though. Interface VLAN 100, IP address, private VLAN mapping. Let me take this out. Wait for it. There it goes. All right, so we should be good to go now. Let's try it. 2. Can ping .1. Should be able to ping .3. Good to go. Should not be able to ping .4. Nice. Nice. All right. Let's do a validation all the way around. Let's go to switch 3. Same thing. Ping 169.204.100.1. .2 should be good, and .4 should be bad. Well, it should be good as a no response. Awesome. Now switch 4. That should work. Yes. 2 should not. Nope. And 3 should not. Okay, we got it to work in the lab. We got private VLANs working. People doubted us. People said this would not work in VIRL. The VIRL is crap. You can't do this stuff in VIRL. Yes, you can. We're running private VLANs. In version 1.2, it did not work. I tried it. I spent a lot of time trying to get it to work. It did not. 1.3, we're working. Once I got it configured right. So that is a good thing. Very good thing. All right. Cool. And I have to remember now, what I forgot is these port level commands. So I forgot switch port, private VLAN. And what are options here? We have association, host association, mapping, and trunk. So I was supposed to do association, host, and the numbers, right? 100 is the primary, and then the secondary. Then we have to do switch port, private VLAN, or switch port mode. Switch port mode. Wow, there's a lot of modes. I forget about this one. We got trunk, we got dynamic, .1Q tunnel. Not use that one. Access, private VLAN. Notice we have to select something here, either host, promiscuous, or trunk. Oh, yeah, switch 4. You get the idea. So, all right, I'm going to stop this simulation. And we might try to hit one more. Yeah, request stop. Okay, good deal, good deal. We're getting better. We're going to leave that on the practice list so that the next time I come back through, we're going to stop here again. The train will continue to make this stop. All right, basic IP routing section. What are we going to do? What are we going to do? IPSLA. Reliable static routing with enhanced object tracking. So, close this down. We're going to close this down. Going into routing mode, folks. Back into routing. This is reliable static routing with enhanced object tracking. Now, I had issues last time remembering the order of putting in the IPSLA, the track command, the IPSLA command, the schedule. Let's see if we get better at it this time. Hopefully so. Hopefully we haven't forgotten everything that we learned. And for this, we're going to need basic IP addressing repository. So let's go to that. Hopefully, you know, we ran a switching topology. We know how VIRL reacts to switching topologies when you shut them down. It's like it. So let's see if he recovers and can carry on here. Basic IP routing. I'm going to give it a minute to calm down. And I'm going to come over here and update our spreadsheet, private VLANs. I'm going to put today's date because, yeah, and we still need speed and concept on that. All right, reliable static routing with enhanced object tracking. That's what we're on today. I'm going to go ahead and close that. And what are the requirements? Get a little water. Good stuff. I worked out just before coming to the lab today. Well, I showered, don't worry, but they kicked us where it hurts. All right, router 1, static route for R4's loopback through DMVPN cloud. Okay, gotcha. Roger that. Router 5, static routes for R1's and R4's loopbacks through DMVPN cloud. Roger that. Router 4, static route for R1's loopback via V146 connection. So 1 have a static route to 4, 4 will have a static route to 1's, 5 will have a static route to 1 and 4. But on this one, use SLA and object tracking to ensure route is valid as long as pings work between R1 and R4's Ethernet connection. Verify 5 seconds. Ensure replies 2 seconds. Okay, configure R4. We want to put a backup static route for R1's loopback 0, L0, through DMVPN cloud using AD of 2. All right, simple enough. All right, I'm going to set up everything except this. We'll do this last. So let's go ahead and start the simulation and cross our fingers. Basic, is that right? Wrong one. Crap. It's basic IP. I started basic RIP routing. Okay, I'm going to let it fully load because one thing I've learned about VIRL is if you try to stop his simulation halfway, you're going to have big problems. Big problemos. So we're going to wait for all these to go active. Well, we're really going to stress it out. We're really going to put it to test here. We'll do our scratch or our configuration. So router 1. Should be easy enough. All right, IP route. And this will be 4.4.4.4.5. And the next hop is going to be DMVPN Cloud 1.5.1.0.5. Yep. I remembered. Awesome. Then router 5. I have something similar. IP route 444 via 4. And to 1.1.1.1 via .1. And let's see, router 4. We're going to put in the backup route. This is going to be router 4, backup route to router 1's loopback via the DMVP cloud, distance of 2. All right, so here goes the IPSLA stuff, right? All right. I wanted to use a command line to help me here, but we're going to say IPSLA 10. Okay, so we put the number. Yeah, we have to do the schedule command later. IPSLA 10, echo, reply. It's something like 5. And where does this go? Replies after 2 seconds. Is that in the tracking? No, it's like echo reply. And I think we have to put the IP here, don't we? 155.1.146.1. Yeah, man. Whew. I know where to find this. All right, we're started up. So let's stop the simulation. Really pushing our luck here. We're really pushing our luck. I'm going to wait till that says stopped. I don't want to look. I know where to look. I know where to find this. But I want to try to cheat through the CLI first. Then I think what we do, so that's the schedule. Then we do track 10, IPSLA 10. And then we somehow create a route, IP route 1.1.1.255.255.255. And we say 5.1.146.1 track 10. Let's do this a different number. PSLA 10, yeah. And then we'll do track 20. Something like that. Okay, it stopped. So let's go to the repository. Let's try to pick the correct one this time, which is basic IP addressing. Boom, there we go. And we don't even need all these routers. But you can't click here and do stop before it even starts, or VIRL just gets really mad. So we have to wait for all these to go green. I'm trying to ensure the success of this mission here. IPSLA 10 echo reply 151.146.1. 5 IPSLA 10 IPSLA schedule 10 forever. Track 20 IPSLA 10. Where does the 2 go? Timeout. No. 2. Something like that. All right. We can guess all day. We just need to wait for this to come up here. In the meantime, I'm going to look down the road. Policy routing is the next section. Policy routing and then GR. Yeah, this is just stuff I have to get faster on. conceptually, I know how this works. At this point, it's just about recall and speed. Recall and speed. So these are going active. I want to end these. We need 1. We don't need 2. We don't need 3. We don't need 6. We don't need 7. We don't need 8. We don't need 10. Let's stop those nodes. I may have done that a little prematurely. We'll see. Let's see what router 1's doing. So need router 1, 2, 3, 4, 5. Yeah. And what do we have? 17,000. Good old 17,000. I hear fan. Like I could tell. VIRL is gonna chug on this. Let's go to the live visualization. We don't use this too often. Usually because it's easier to select an object and shut it down using the web interface. I was thinking, what if I do a Wireshark capture on this lab? What am I going to see? But honestly, I don't think I'm going to see anything. We're just going to see pings. Just regular ping packets at certain intervals. That's all. Nothing. So I take that back. No need to do any packet captures here. And router 1 is booting up. That's good. Good sign. I'd told these guys to stop, but let's try now. There we go. Okay, they're terminating. Terminating. Router terminating. Terminate these switches. We don't need you switches. Go away. Come back another day. Just let me play. Building configuration. No CPU hogs yet. No hogs. That's when you gotta worry when you see the hogs. CPU hogs. No hogs. All right. Building configuration. Router 2, we don't need router. I just put it there as a placeholder. All we need is 1, 4, and 5. That's all I'm asking. Just cooperate with me here. Hey. Okay, we can do this. This is easy. Router 1, that's all I want you to do. Good deal. Router 5. All I need you for? Still building. All right. So I can play with this here. Let's say, there's a CPU hogs. IPSLA. We give it a number, 10. Then I have to hit enter. All right. That's right. Okay, good so far. I'm going to put it on here too. Echo. No. ICMP echo. Shoot. Okay. ICMP echo. Okay, we don't need reply here. ICMP echo 151.146.4. Okay, that's all we need. Man, I gotta remember this stuff. And we should say every 5 seconds, right? I think it's just frequency 5, timeout 2. Huh? Oh, milliseconds. Timeout is less than 5. Okay, frequency, number of seconds. We did that. Timeout. Timeout in milliseconds. All right, let me think about this. Ensure you receive replies in 2 seconds. So I'm going to send it every 5 seconds, but I expect the reply to be in 2 seconds. Well, the lowest I can set it is 5,000. Threshold. Can I change the threshold? I can. Ah. Sneaky, sneaky. Heine, you are sneaky. You're very sneaky, but that's okay. That's why we love you. All right, so that's what I got wrong. It's IPSLA 10, ICP echo. In this case, frequency 5. Threshold, it's already hard to spell. 2000, timeout, 2000. Okay. I was off. Conceptually, I was good. Speed, way off. So then we do IP, let's exit. IPSLA 10, schedule 10. Start. I'm not sure what you're saying there, BB. This is a networking channel, man. Network engineers. So we want to say IPSLA 10 start time. Now, did I get that right? Start time now, yeah. IP, you know, I don't think I have to put a need help and healing. Man, sorry, my friend, you are in the wrong channel for that. IPSLA schedule 10 start time now. I don't think I have to put, I was thinking I had to do IPSLA schedule 10. Yeah, that's all we need. Forever. I think that by default it's going to run forever. I could do a schedule here, like a real schedule. Okay, then we need our tracking statement. Track 20. IP SLA 10. I have seen where people will put reachability, but honestly, I think that's all I need. Track 20 IP SLA 10. It's going to be either up or down, right? Track IP SLA 10. Yeah, let's try it. Let's try that. Okay, this is on router 1. So show IP SLA. Only one failure. Show track. Yeah, I think as long as this is up, which means the IP SLA is up, that's all the tracking, the object tracking cares about, because the yeah, we need to be doing this a different router. This is router 4. So 4 is up. Hello, router 4. Let's put all this into router 4. And actually, this is incorrect. IP SLA 10, ICMP, no IP SLA 10, ICMP echo 151.146.1. And frequency 5, threshold 2000. And timeout 2000. Then track 20, IP SLA 10, and a route. Put both these in. Boom. Show IP SLA. Unknown. Unknown. Why is it unknown? 155.1.146.1. Last run. Hold on a second. How can there be 8 minutes 27 seconds ago? This router hasn't even been up for 8 minutes. Okay, that looks good. ICP echo. No schedule. Third. Okay, now we're talking. This is an interesting caption. All right, so I could see this being. I can see this being in a diagnostics or something like that. This is how it should look. So now show IP route. I love this command, show IP static route. I learned this because of studying for CCIE. I'd never used it before. T, tracking object. Via 155.1.146.1. Good deal. So now let's test it. Let's actually shut down. And see what happens. Okay, now it went to down. Now we do show IP route. Okay, now we're going through the tunnel. Or are we? Show IPCEF 1.1.1.1/32 through the tunnel. Okay. Not sure what the H is. Oh, that may mean that we have multiple paths, but this one doesn't work. Not sure. All right, well, I think we got that. Let me check the key and see if that's what we need to do. Okay. This is something I probably should have done, and that is this. IPSLA 10. IPSLA 10. ICMP echo 151.146.1. Source. What else can we do here? Source interface. GI 01146. Yeah. That makes sense. Okay, and it should be down, but let's bring it back up. I think I'm doing debugs too. Yep, good to go. All right. Well, that's a good review. I'm going to do some other things here for the rest of the evening. Thanks for tuning in to the LAN Tamer stream. Thanks for hanging out. I hope you have a good rest of the night, wherever you are. And hit that like button. Subscribe if you haven't already. And come and see us again. Should be streaming tomorrow night if all goes well. According to plan, we'll be doing some more basic IP routing, policy routing, and probably some more SLA stuff. So we shall see you soon back here in the LAN Tamer stream. You have a great night.